got it. Share. Okay, so plan for today is to do at least lesson 4 from current unit, possibly 5/6. We'll see how it goes. But you should have the relevant access to lesson 4 from the current unit. And let's see what we'll go to bubble 1. It's another make lesson where it's just an example and we recreate it, but a little disappointed with how much of the example they provide. I think would have been a lot of benefit in starting, not necessarily from scratch, because there's a lot of design elements, but either way. Okay, so hit run. Let's try rock to tie, try paper to tie. Okay, we got one. We got another one. We lost one. Okay, and let's see if there's a end game included. Is it a race to 10, I'm guessing? No, doesn't look like there's an end. Okay, so then we are definitely going to add an end to it, and maybe that's how we will extend this lesson is as we go through, we'll add a couple things, like perhaps some sort of visual. I mean, obviously we know how, or you should know how rock, paper, scissors works, but maybe have the icon change color for the winner, just as a quick visual cue, and also an end game. Let's see how much they give us here. So you can go ahead and get to this. Okay, the only instructions it looks like are do it. So here we go. Let's give it a go. All right, how much do they give us? They give us all of the design elements. Nice. Buttons, fantastic. Text areas, lovely. Good names, buttons, player output, computer score, player score, icons that don't do anything. Lovely. All right, well, what do we get? We get a list, an array of 3 strings, which correspond to icons. The icons for rock, paper, and scissors are lovely. And a list that corresponds exactly with strings that are the words of those icons or the choices. And it's nice they've made them, and it's not an accident, parallel, so to speak, as the second string is the word paper in choices, and the second string in icons is the paper icon. So we can use the same index when setting or checking words and then setting an image to setting the image property to its icon. And we've got a couple of empty variables for keeping track of score. And we have only have 3 events or event handlers: rock button, paper button, scissor button. And it calls update screen. And it looks like, well, update screen is our main function, which is, it has a bunch of return functions, which is, the point of this entire unit so far. Well, really the entire unit, just we look at it differently. Okay, so again, the point of a return function is not just to do a thing, but to equate to something, or to calculate something, or to check to see if something is true, where you can write the entire command in a single line, and it will check based on these two things. Always, I can't think of an example of a return function, or at least I can't think of a useful example of a return function that doesn't have parameters. The whole point is you want to check to see if something is true if these things are true. In fact, most functions moving forward, or at least moving forward to advanced stuff beyond this class, will have parameters at some point. It's sort of, the point. And so it looks like we have one function is called random choose, and that is what makes the computer choice. And so this one actually, oh no, these are the ones, the return functions are the things we have to build. Lovely. Okay, so this actually does have a fair bit of meat on the bone for us to build together. And so we're creating a variable every time we call update screen, which is every time a button is clicked, we're resetting a variable called computer choice to be used with all the conditionals. And that is going to be one of the three things at random. And then we are creating a variable called winner based on what the user has chosen and what the computer chose at random. And decide winner is our, calculate function. And then based on who the winner is, if the winner is player, well, okay, so decide winner has to return either player or computer. And depending on what it returns, which is this, then it's going to calculate and decide to set property of the texts and update score. Computer score goes ++, or player score goes ++, or draw. All right, so we have to do three things. We have to have find the icon for both computer and for player. And we also need a random choose, which let's do. When does find icon get run? Okay, find icon gets run after we choose, obviously. And then decide winner. So we're going to do this in the order of, well, the order they're called. Okay. First, we need to get the computer to choose one at random. Then we need to well, actually, we need to get the computer to choose one at random, and then let's work on setting the images, or setting the icons, which are just images using icon properties. And then based on those things, we will figure out a winner. Now, the choose at random, we need it to return a word. Okay, we need to have it return one of these three strings. And that word, we really could have it return an index. Because if we have the index, have it return a 0, a 1, or a 2, choice is index 0, choice is index 1, choice is index 2. If we have it return that, it would be easier to set an icon for the computer. Because right now we're just worried about the computer. Oh, no, because we're using find icon, we do have to return a word, because we're going to use find icon for the player choice also. And we're not choosing an index. We're choosing I guess you could set it up as an index. It's fine. let's just return a word because we'll be able to console log it better. Okay, so random choose. This is for the computer to choose one at random. And so first, we are receiving a list as our parameter, and random choose is sending the list called choices, which is a list of the strings, not the icons. That's fine. And it's really the only list that we're using, so it's not critical that random choice receives a parameter. We could just use it, globally, but it's fine. Okay, so first we need to choose a random string or random index. Let's just call it choice. Well, first we need a local variable for something to return. So we'll set a new local variable to choice, and choice is one of the elements list at index, and we need a random index. List at index rand number. There's only 3 things, so it's going to be 0 to 2. Okay, and then we're going to return. Oh no, this is fine icon. Excuse me. We're working on random choice. Okay, return. Well, we really could just do return list at index. What am I doing? We could just return the randomness. That's fine. We're returning one of the elements from list. That's all we need. And that's going to equate to one of the strings from that. And we can prove this by console logging computer choice after it's called. And when we hit run, is it calling anything? Okay, so no matter which one I click on, it's going to give me a random. You can see down here in the debug console, it's just picking one at random, even though I got paper 4 times in a row. That's not an unreasonable string or stretch. Okay, so computer choice is picking one at random. Great. It's one of the 3 strings. So we can then, all right, so we've got one at random. Let's set some icons. Okay, so the find icon is using player choice as the parameter that it's sending to. Player choice is what's being received when update screen is called. So okay, so update screen is expecting a parameter, and that's where we get what the user chose. When they click on rock button, the string rock gets sent. When the paper button, the string paper is set, and that is that. Okay, so find icon is being called to set this image and this image. This is player output, this is computer output, and it's being called, it's the return function. Okay, because it's a return function, it's all of so we've seen set property of one of the images, set its image property to, a string, but this whole return function, when you call this return function, you call the function with a parameter, it's going to equate to the relevant string that will set the image property, because it's all set up that way. It's set up for you. And you're going to do a little bit of the setting up. But the point is, once you have find icon made, you don't have to worry about it. So we're starting to get to the point where these return functions are actually useful. Before, we just had such simple things as the output that it really didn't make sense to go through the time of making a return function. But here it does. And let's see here. So find icon. We want find icon to return. Okay, so it's being sent a string. We need to loop through our list of choices. And if the choice matches the player choice, we want the icon at that same index. Okay, so if you're checking everything, every possible combination, you definitely need a for loop. And our loop only needs to be, we only need to do it 3 times. Technically, you could do choices dot length, just to, it's a best practice to use dot length instead of hard coding, but we know it only needs to loop 3 times. So 3. And so we're using I as our counting variable. And we're going to check if icon name. So we're setting, the whole point of this function is to set it up so it doesn't matter which person's choice it is sending. It's just going to compare whatever string it gets sent, rock, paper, scissor, depending on what gets sent, and it's going to return the appropriate icon or the string that means the icon. So if icon name, which is the name of the parameter coming in here, if icon name double equals the index on choices index I, then we want, well, we're never going to have more than one match. We can just go ahead and return icons index I, because that's what we want to send back. Now, we could create a local variable that says like called real icon or something like that, or correct icon, and then set correct icon here and then return correct icon, but we don't need to. And return also ends the loop. It ends the function. So it will stop looking for other things, which is fine because we're never going to have 2 matches for player output and 2 matches for computer. It's just an end. So in theory, this should work. Okay, yeah. So every time we click, we're at least getting the correct user choice, and it's picking one at random. Okay, because we've already had the computer choose one at random. Wow, we are almost done. Looks pretty good so far. All right, so now I'd say this is the main, I don't know, it's hard to say what's the main one because it doesn't work without all of them. We now have a player's choice, a computer choice. We've set the icon, we just need to compare them. And we are going to compare them with decide winner, which is here. So we're receiving player choice based on the button that gets sent. We are creating computer choice based on the random that gets sent or gets returned. And now we need to figure out what winner is based on the return function called decide winner. So we are setting this new local variable called winner to whatever gets returned when we call this return function. And we are looking for a return because we're comparing winner. You can see here, winner equals draw, winner equals player, or winner equals computer. We are expecting one of these 3 strings to come back based on what gets sent to it. And so decide winner is receiving the 2 things. Okay, if how can we do this? Well, we can take, this could be a long, I think it's going to be a long conditional. The question is, so there are 9 combinations. right? 3 for the player and 3 for the computer. We know anything that's a tie that's the same, it's a draw. So let's just knock out 3 of the possibilities, and that will only leave us with 6 to deal with. Acknowledge or sneeze. If player choice double equals computer choice, capitalized the same way, computer choice, then we can return draw. That will end the function, which is fine. We only want one possible output. Now, we have a couple choices. We have 3 player choices, and we need to compare it against 3 computer choices. We could do a series of, if player choice is rock and computer choice is paper, return computer, and so on. And every one would be a compound situation. The way I think of this is setting this up as 3 for the player choice, and then within each one, 2 for the computer's choice. Now, the computer only has 2 choices because we've already knocked out any possible tie. So we have, once we get rid of ties, the player has 3 choices. Player still has 3 choices. Are this line 78. I'm going to put some spaces in there so you can see. This line here. So the computer, once we knock out ties, we have 3. We still have 3 choices for the player, but the computer only has 2 choices, because if it matched what we are choosing for the player, it would have already been taken care of by this first one. So these 3 right here, this one, in fact, let's do, that'll be all right. You'll see once we start typing player and stuff like that. So first one, if player choice double equals rock, in quotes, because we're sending strings, initial caps, rock. And this one will be if player choice double equals paper. And the only other one would be for this line 94 would be scissors. That's the only other possible choice. So here we are, oh shoot, if it's rock, and rock it's already due. Okay, so we're gonna have a bunch of, here are where our returns are gonna go. Return, 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 return. And we are expecting a return of either draw player or computer, spelled capitalized. Okay, so it's only gonna be player or computer. So just to make sure that we hit every possibility, we will go, when player chooses rock, we'll do computer scissors, and then the other one would be computer paper. Player chooses paper, computer scissors, the only one would be rock, and the last one is player scissors, so this would be computer rock, and there was other one would be paper. And it's just think of it as a loop. It's a bit much if you just start, your eyes start to blur. But so we don't have to worry about player rock and computer rock. The next one would be computer choice. If computer choice double equals paper. And so if player is rock and computer is paper, return computer. Because paper beats rock. And the only other scenario is rock and scissors, so return player. Okay. If player chooses paper, that means computer has to choose scissors. If computer choice double equals scissors, and we need quotes for that. So if computer choice is scissors and the player chose paper, that means computer won. And now that I think about it, there's probably an easier way to do that if you do stick with the indexes where, it works out to be the same, actually. You're comparing 2 against 1, 1 against 2, and 0 against 2. Okay, so we have player chose rock, player chose paper. The only other scenario is player chose scissors. So that means if computer choice, going back around, scissors, if computer choice equals rock, that means return computer because that rock beats the player's scissors. And if player chose scissors, and that means, you can just sort of start to see the pattern. As long as you stick to a pattern for creating your conditionals, the results are going to be in a pattern. And I do think these sort of nested conditionals sort of make a little more sense. They might not make more sense to you rather than like, something. If computer chose rock and player choice double equals paper, one of these sorts of things might make sense to you a little bit more. And then it would just be 9 else if statements. That's fine. It would work the same. But I don't know. The way I think about things is a little more like first is one choice, and then based on that choice inside of it, you can figure out the results. Okay, and let's see if this works. Okay, draw, good. Okay, rock beats scissors, good. And we're already getting points. Draw. Fantastic. Lovely. All right, so that's the app completed for what AppLab thinks, but we are going to add some more features. Let's add an in-game scenario, and let's do it after we check for the score. Let's what's that? Yes, this is my mandatory addition. Let's have we can make a new screen, but I just want to have something pop up, and why not have a giant button pop up? And we'll set the text to, you could make it a text area or something. I don't know, but I do want it. I'm going to make it so that it's a player click to also reset. I don't know. We'll just see. Let's call this a game over button. And we'll set the text based on who wins. And let's start it out hidden because we're only going to show it once the game is over. Okay, and it's called game over button. Okay, so after we update screen, we update the score. Let's check game over. And so conditional, if, and we only need one conditional, and it's if whatever. Okay, and we can, if either player gets to 5, let's just make it to 2, best 2 out of 3. Okay, so if computer score is greater than 1, we greater than or equal to 2, greater than 1, it's fine, meaning they scored 2. Oh no, let's do an else because we want, well, it wouldn't be an else. It would be a different if, because if neither player score nor computer score is above 1, meaning has made it to 2, we want it to not end anything. So we couldn't put it in an else. We could technically put it in a second else if and have computer score and then another else if, but it's the same thing. So if computer score is over 1, meaning they've won 2 of them, we're going to do a thing. And if player score is greater than 1, we'll do another thing. So if either one has made it to 2, they've won the 2 out of 3, we need to set the property of game over button, set its hiddenness to false. In other words, show it. And yeah, then we want to set the text, which they didn't even give us a set text block. I guess they didn't expect us to do this. Set the text of, let me just copy it. Set the game over button text to, this is the computer side. So in string, computer wins. And then how about a new line and computer score. Oh wait, that would have to be in its own, because it's its own what's it called, variable. Computer score plus, how about a dash, because it's a good way to show a score, plus player score. And then we're gonna do the same thing except reversed for if the player wins. Let's go, how about you win. And we'll do player score followed by computer score. And then that will get us most of the way. And let's see here. Oh, we need to, wait, hold on. Why did it not do it? Draw. Computer wins. Okay. All right. So that works more or less. I can't stand the color, but that's neither here nor there. And it's kind of strange that they were there first with computer wins or player wins. maybe verbiage of U1 or, and I don't think the computer needs the excitement of an exclamation point. It's a computer one. How about you lost, period, sad period. And you won. Okay, so the reason I chose a button there is so that we can use its click to reset the score. And in fact, let's add a play again at the end of our text. So this is a player score is a variable, so we need to add, let's add a bunch of new lines, backslash n, backslash n, backslash n, followed by play again. And play again ends in a quote. That's good. Let's put the same thing on the line for player score or player win. And I think that will work. Play again. Good. Okay, so all we need to do is an event handler for the button that will hide it and reset the score. And do we have something else? Also hide it, reset the score, and set both, essentially set it back to its starting position, because the icons as we start as question marks, but if we don't reset them, they'll still be whatever they were for the last go, which doesn't make any sense. So we need an event handler for our button, and the button is called game over button. On event, game over button is clicked. We want to set some properties. We want to set the property of game over button to hidden is true. Okay, and this should work. Let's see what happens. Beautiful. Okay, we want to reset player score and computer score. We can just grab these from up here, and we still need to get rid of the var because they are. And so that will reset those. But then we also need to set these text areas back to 0. We could just set the text areas back to 0, but it wouldn't reset the variables back to 0, which is needed if we're going to keep playing through. So let's do a couple more set properties. Well, set text, but we don't have it. So set property of, this is called computer score and player score. Makes sense. Computer score, is it called computer score? Computer score output, set its text to computer score without quotes. And that's a mistake I'm still seeing a lot of you do, is use strings when you really mean variables, or use quotes when you're still trying to use variables. So player score output, its text gets player score. And so this should work to a certain extent. We go back here and it gets set back to 0. Wow, a lot of draws. That's impossible. 2 to 1, and it gets reset. But we still need to reset the icons back to their starting position, which those are called computer output and player output. And the string is, or the icon is called question, which we could get from the set property thing, but that's fine. We want to set the property of, those are called the outputs, set the images to question, and do the same thing for computer output. Set its image to question. Okay, let's see if that works. It works. Okay, so that's pretty good. How about let's set icon colors just to see how that works. Let's see, computer output, icon color to, let's see what red looks like when we go back through. This is not in the right place, but okay, so that's going to work well. So icon color is the property we want to set. We're not going to put it there. We need to figure out where to put it. We need to put it in the, when it chooses. Okay, so if winner is player, let's let's just drag it up from here. That was just a test location. Come on, here we go. 4 more. And there we go. Okay, so if winner is player, computer output gets red, and player output should get, I don't know, green. Why not? Player output get green. I think it'll take the string. And let's see if that works, which I have to get one correct in order to. Okay, so it works. There we go. And the opposite if computer wins. So if computer output, let's just switch these, the colors to work. Player output, computer wins, player output gets red, and otherwise, computer gets green. Okay. Clearly, we need to set them both back to black at the end. We also need to set them both to black if there's a tie, because it's still the way it was. So we need to set them both under draw. Let's set them both to, is black part of the dropdown? It is not. Let's just call them black. And I guess it's lowercase, but whatever. Yeah, initial caps works there. And we also need to set it back to black when we go back to the beginning, which is on our game over button. And that might be it. Draw, good. And I'm going to change it so that the button is smaller so that you can see the result of the last. And really, we could have just done, I'm pretty sure you can do a click for the text area that's there at the beginning. Okay. Oh, and then the text is too long there. So I'm going to get rid of a couple of these new line situations. Oh, that's in our check. Whatever thing. How many did I do? 3. Let's just do 1. And get rid of a couple here. And I think we're good. We can probably ship it. Yep. There we go. All right. I think we're good. Ship it. That's it.